quiz. Did you get very far? Okay, so let's look at the first one. And again, I would suggest that you just draw yourself a little blueprint here, what's going on. We're gonna buy a $54 sweater, so we're gonna start with $54, and then we're gonna be doing something to that number. We're gonna be multiplying it by a number that represents 20% off, and then a number that represents a 7% add-on. Okay? So I go ahead and use these minuses and pluses to remind me what I'm going to be multiplying by. If I am taking away 20%, then I'm going to multiply by 0.80. It's 80%, kids, but don't multiply by 80. You'll get way too big of a number. It's 80%. So 0.8. Now, if it's a tax, it's an add-on. So that means instead of taking 1 minus 20, I'm going to take 1 plus 7%. So that decimal is going to be 1.07. And then I just I type all that into my calculator and round it off to the nearest cent. What does it say? 46.22. Is that right with everybody?
Yeah.
Is that good?
Yep.
Yeah. Okay, so whatever number you start with, you're going to be multiplying it by whatever's going on in the problem. In this case, we have a discount, which is minus, and we have a tax, which is add. So what if we had a coupon? That would be minus. What if we had a tip, like in a restaurant? That would be plus. So there are discovering things. You're either going to be subtracting or adding the percentage. Got that one? Okay. Now the next one is our mixture problem. So we start with the general format. And the idea is that you are adding two solutions together and ending up with a final product. And all the way across is amount times percent, amount times percent, amount times percent. So it's not complicated. So I suggested to you yesterday that you recognize there are 6 things in the problem. 3 amounts and 3 percentages. So in the problem, they give you a whole bunch of that. So let's just fill in everything that we know. So we have percentages of 56 getting mixed with 68 to end up with 60. Right? There's no math involved there. I am just plugging in the percentages that they gave me. Now they gave me one other number. In the problem there's only one other number, and that is 3. 3 gallons is an amount. It is the amount of 60. So it goes here.
We put X.
And we put X here because the question is how much 56%? How much X? Right?
Yep. 3 minus X.
Now, I don't know what this is.
X plus Y equals 3.
Well, okay, if you think of that as Y, X plus Y equals 3.
And you get Y by the side.
So Y is 3 minus X. So this amount is 3 minus X.
What would be the other one? I like that.
Okay, wait. We're doing this problem, and that's the way this problem's done. I'll do one more example of this in a minute, but let's finish this one. These two have to add up to this. Kids, you have a big bucket. I have 2 pitchers in my hand. Whatever I dump in here and whatever I dump in here That's the total that's in the bucket, right? So this plus this has to give you 3. When you add these two together, you have to get 3. So now we solve it. And that's regular equation solving. So that's a little bit of distributive here. Now we'll get all of our x's together. So what is that? Negative 0.12x. And I'm going to go ahead and subtract that over. And this one works out nice. It's 0.24 divided by 0.12. You got a calculator, so use it. That would be 2 gallons. All right, yeah, there's a little bit of room on the paper still. Evan? I distributed here. This is a distribute.
Oh, okay.
So you gotta take 3 times 0.68. That's a parenthesis. You have to distribute the 0.68. All right, so you got a little room. Let's do one more of those. Let's do one more of those mixture problems, okay? So let's say how much, I'm not gonna write out all the words because it takes too long, but how much 52% solution needs to be mixed with 81% solution, let's say, no, 8 gallons of 81% solution to get a 63% solution. So I know my grammar is not very good, but you get the idea. How much of a 50% or 52% mixture needs to be mixed with 8 gallons of an 81% mixture to get a 63% mixture? So our formula, again, is amount times percent plus amount times percent equals amount times percent. And I have 6 things to fill in. So what are my percentages? Here we go.
So you have 0.52.
This one's going to be 0.52.
0.81.
This one's going to be 0.81.
And 0.63.
And this is the mixture, the final mixture. It's the one that's over here all by itself. It's 63. The only other number I have in the problem is 8.
Yeah.
And 8 gallons of 81%. So the 8 goes here this time, right?
Yes.
And this is still X because it says how much
Yep.
of that?
So that's what
8
would that
plus
be?
plus
8.
0.81.
Yeah.
What's this going to be over here?
X
8.
plus 0.81.
X plus 8. Not X plus 0.81. 8.81 is a percentage. It's X plus 8. It's the amount. It's the total amount. The amount in this picture is X. The amount in this picture is 8. They are going together to make 8 plus X. So what I'm trying to get you to see, kids, is I know we haven't done a ton of these problems, but every single one we've done, you had an X in this spot, right? And then you either have a number here or a number here.
Yes.
If the number is here,
It's X minus
This is gonna be 3 minus x. So if this were 7, this would be 7 minus x. If the number is here, this is gonna be x plus 8, or x plus 12, or x plus 92, whatever it is. Every time, they're never different. Malcolm?
How do you know which one goes?
Malcolm, it's in the problem, sweetie. Look, it says 8 gallons of 81. So the 8 has to go with the 81. So if the 8 goes with the 81, then this is the empty, this parentheses is empty, and I put in x plus 8. The problem's on the paper, but it said I had 3 gallons of the 60, so it went here. That means this parentheses was empty. If this is the empty one, it's 3 minus x, because these two have to add up to that one. So every time you do it, you're gonna have your percentages. So I'm just making up percentages here, okay? Every time I do it, I got my percentages. This is always gonna be an x. If I know I have 14 gallons of this, then that's gonna be x plus 14. If I know I have 14 gallons of this, this is gonna be 14 minus x. They're always the same.
Would it be different if it was x minus 14?
Yes, it would be different. It's never gonna be x minus 14.
Okay.
Never. They have to add up to 14, so it's gonna be 14 minus x.
Okay.
Olivia?
Even though the first one was 3 minus x, and the second one is x plus 8, how do you know like if it's positive or if it's like adding or?
If you're finding the total, it's gonna be adding. This is the final mixture. You're adding this amount to this amount to get this amount. It's always add.
So then if it was like the other way, like if the second part was like the first one, and it would have been 8 minus 3, and if it would have been the other side?
Yes, 8 minus that. So this is, you just do the arithmetic. So it's 0.52x plus whatever 8 times 0.81 is. And then 0.63x plus 5.04. You put all your x's on the same side. So negative 0.11x equals, subtract over there. It's like just a regular equation.
I know that because I didn't.
And then divide. So you divide both sides, x is about 13.09.
Wait. How did I do this so wrong?
We didn't.
I don't know. This is 0.52x. This is 6.48. Did you distribute here? You have to distribute.
Yeah.
Put the x's on the same side.
Oh, but I somehow got 5.44 instead of 5.04.
I may have copied it wrong.
No, you're right. I'm definitely wrong.
Yeah, I got 13.
Nope, I wrote it down wrong.
All right, so here we go. We're going to take our quiz now. What?
Oh, I was just gonna say, so even if you were to come up with a negative here, it's always gonna come out positive.
Never come up with a negative there. You're dividing a negative by a
Yeah,
negative.
no, so I'm saying like your answer always comes down.
Your answer will always be positive. How could you have negative gallons? Okay. So here we go.
That punishment is made for the punishment. But what about the president trying to make a small mistake and they always
Yes.
they won't make that mistake against
Yeah,
the
50 cents.
I think there should be some sort of if you're good and you want your letters, I think that it's easy to go get one.
All right, so here we go.
Even wearing it for 5 months straight without a mistake, like, if you committed detention, that's 2 days off.
All right, here we go.
Yeah, to them, your reward is.
You know what, Andrew, if you just